And the online agenda and slides are at the usual place. I guess maybe not the usual place. They moved things around a bit this meeting, right? Okay, here's the note well. So note it. All right. We have people using the audio streaming and the recording, so please be sure to use the microphones. Please state your name and affiliation before speaking. And then we need some volunteers for joint note-taking. So who wants to help out with making sure we have notes? Okay, Pascal, anybody else? And we do that via Etherpad. Yes.
Yeah, when you go there, click on the link that says Etherpad-97, and that'll take you right to where you can enter in the notes for some good crowdsourced contribution.
Okay, and then there's also Jabber. Okay, and Lou's volunteering to be a Jabber scribe. And I'm sorry, I don't. Kelson is going to also be a Jabber scribe. Very good. Wow, that's going quickly. Thank you for the volunteers. The online agenda and slides are again at the on the website. Yeah, at the new location. And that brings us to blue sheets.
Give me 1 second.
So please sign the blue sheets. That gives us a record of who's here, and it also helps make sure we have a big enough room each time. I looked at the wrong one to fill that in. Okay. So Lou will be bringing that to you in a second here. So we have some documents. We've moved to working group, IETF Detnet architecture and the Detnet problem statement and the use cases draft. And then we also just recently adopted the data plane alternatives draft. And we haven't currently identified anything as a candidate working group document, but I think in the course of today we will probably discuss moving in that direction with an additional draft. So here's our agenda. Any bashing for the agenda?
Yeah, I don't think we ended up with any changes as often happens in the last minute, so I think we're okay.
Okay. And please use the mailing list. That's how we build consensus in IETF. It's for working group discussion and for making decisions. We want to resolve open issues there, reviewing changes, and etc. And we're probably gonna, now that we've got a data plane alternatives draft, we're probably gonna want to start moving towards the point where we get a data plane draft. So please read what's on the mailing list and respond to it. And then based on how much discussion we have and progress we make, we will schedule meeting times. Okay. We have an IPR disclosure process. It's not not the IETF required process, but it helps making sure we find out about any IPR conflicts earlier and don't have trouble progressing our drafts. So prior to moving to the next step in the working group process, that means before we turn an individual draft into a working group draft and before we move a working group draft to last call, we ask for an IPR compliance statement from everybody who's listed in the draft.
And actually, we have hit a couple of times where we had a surprising IPR disclosures during the adoption phase. So it's good that we did the process. And to the authors, I'll say, think about if you have a big document and you're going to add a very small piece that's IPR encumbered, think about whether you really need to add that piece. and really does it add value to the document. If it adds value and it's really important, do it and then disclose it. If it really isn't critical to the document, it's just easier for everyone if you don't include it. You know, if it's just something that's there as an informative piece of text, it doesn't really have to be there. I'm not saying don't publish it, just publish it in a separate document and point to it. But don't encumber a document for something that really isn't a core piece of the work being covered in it.
Okay, so now we will look at where we are in our deliverables and our milestones. We're moving along. We've adopted an architecture draft and a data plane draft. We've got some drafts for the information model, and those are moving along. Yang models, perhaps it's been a bit early to get Yang models, but it's probably about time to start thinking about Yang models, and we'd welcome.
We don't have information. Could use more.
Right. Yes. Well, we have some individual drafts.
The private comment I was making is we actually don't have.
We don't have it adopted.
We don't have an information model yet. We do have a couple of individual drafts that are on the agenda that are going towards that way. But if you feel like you have something to contribute in this area, it'd be really good to contribute, and you can do that either on list as an individual document, certainly in the discussion today. But now would be a great time if you have ideas and you'd like to contribute to the group, and now would be a great time to give us those ideas in any way you feel, including an individual draft.
Right, and including if you haven't read and commented on those drafts that we have now, also reading those and giving us feedback on them to the list. Okay, so use cases we are in pretty good shape on. We continue to hone the use cases draft, but I think it's largely done. And service model, we should be hopefully moving towards a working group draft on that. Okay, any questions and comments?
Yeah, we definitely are a little bit behind of where our milestones had hoped we would be, but we are making progress, and that's not too uncommon for working groups to be a little late on the milestones. We're not too bad, but we really need the group to come forward with proposals, particularly on those last couple of areas, to help us keep moving. So if you have ideas and you think they're relevant, don't wait, contribute to the group, please. Okay. And with that, we're going to move on to Ethan.
I'm Ethan Grossman from Dolby Laboratories, and this is the Detnet use case update. So the presentation for today follows the same basic form that I've done for the last few times, and I've included a lot of this material in here for the sake of completeness, but I'm not necessarily going to read through all the stuff. I'm just going to kind of hand wave over it and get to the new stuff. Did I push the wrong button? No, okay. So the current draft is 11, which includes the new wind farm section of the utilities draft, which was contributed to us and integrated. I'm not going to go over that. It presents a number of details that you can check out if you're interested in that particular use case. So the goals of the draft are unchanged. The main one that's of interesting to me is the yardstick for functionality of any proposed design, in the sense that I'm trying to keep an eye on the use case draft and at the same time the proposed architecture, and see if there's any areas that either seem under investigated or might be diverging. All right, let's try. Okay. So in that vein, there were a few discussion topics on the list which brought up topics that were of interest to the use case and clarifying them. And I wanted to just briefly mention what the results of those were. And I wanted to bring up a new topic, not that it's a new topic, but it's a discussion for this group regarding the area of security for Detnet, because I feel like that's an area that is very important to all the use cases, but I haven't seen a lot of discussion about the specifics of it. And I just thought it would be good to kick off some questions about that. So that's going to be the main part of the discussion today. As usual, we'll continue to work on the use case draft. One aspect of it is that for Detnet, we're not going to have a requirements document. We're going directly from use case to the architecture and so on. And so it may be that due to changes in the architecture, we need to change some things in the use case draft. For example, we took internet scope out, and that was something that was in the use case originally and had to be taken out. So that's why that direction is there. So the use cases that we have fall into these groups. These have been presented several times, so I'm not going to go over them again. They're stable at this point. The common themes also have been presented a couple of times, so the slides are here. I'll just page through them so that you can look at them at your leisure, but I'm not going to read them. So here are the common themes. Again, I hope these are mom and apple pie by now. We all know them. Page 2. Okay. So the topics that I thought were interesting from the list having to do with latency matching was one question that was mentioned in the use case, but there wasn't explicitly a discussion in the list or in the architecture. And so it seems that it's still on the fence as to whether that's something that would be provided directly by the network or something where applications would have to adjust those on their own. That was, again, a topic, but wasn't conclusively decided. Time accuracy. If an application wants to know that, they can query the existing time protocols. There's not going to be a way to query the Detnet API for that. Question as to if you distinguish the availability or reliability in terms of like how many nines your particular flow needs. We seem to agree that that's something that needs to be on a per flow basis, but exactly how that's configured is still open. Presumably the network would provide some options from which the application would select. Another question that came up to me when I was reporting out on Detnet to the Avenue Alliance was, is there a migration path from the present day technology to what will eventually create as Detnet? In other words, they're saying, well, we want to do something now. We understand Detnet's going to be great. It's going to allow us to access AVB style quality of service from layer 3, and we want to be able to do that. But in the meanwhile, is there anything we can do? And basically I said, well, we didn't have a formal plan, but it was brought up that there's some work in the IEEE which is going on, which might be relevant. And I did want to pose the question generally to the group as to whether anybody thought it was important to do that, to be able to express a migration plan. So if that's an open question, we can discuss it on the list, or if anybody wants to comment on it. So when I was idly considering what to do about security for Detnet, I found a guy, Andrew Hacker, who was a security expert, who was kind enough to review our drafts and make a number of suggestions about how we should be thinking about security for Detnet. And just things we should be looking at. So it's a laundry list of many essentially questions and a few direct recommendations. And I just wanted to bring these up to the group, and there's no time to even get through listing them all today. There's quite a number of them if you see the slides, but I feel like they're important. And if anybody has any comments about how any of these comments can be addressed, I think we need to have a way to address them one way or another, even if it's to say this is for sure not an issue with Detnet. We know that if we're doing it this way, we're not going to have that problem. But I think asking the questions and having them be openly considered is important. So the security strategy so far we've had is, well, we're not going to break security. That's our strategy, is don't break anything. But it just seemed like a little more detail might be helpful. So what I was thinking was, well, we'll enumerate the various Detnet technologies that we end up selecting, and from there determine what holes there might open up or what aspects of it that might require us to do something specific with respect to either specifying an associated protocol for the security or having to modify one. And then so moving on to Andrew's recommendations, he was pointing out that an examination with respect to confidentiality, integrity, and availability is a common way of analyzing this. I am not a security guy, so all this stuff is fabulous and new to me. If any of you guys know about this stuff, I'd love to get your contributions, but for now I'm treating this as a naive user here and just looking at this like, oh, okay, we should be doing this. So this is one way of ordering the information in terms of the confidentiality, which is sort of about encryption and that kind of thing, versus integrity, which is more about signing and stuff like that, and availability, which is, does the data actually get to where it needs to go? I've then sliced the presentation that follows by Detnet function. So for each function, what is it we should be thinking about? Because I thought that just seemed like the most logical way for us to address it. There were some overall suggestions. For example, should we have a Detnet security document that's sort of like a central repository for information about security for us? In other words, all this stuff would go in there. There was some discussion already in the various drafts. Should they be consolidated together? I don't know. This is another question I have for the group. If anybody has any opinions, I'm willing to take that on. If not, then we don't have to. Another thing that was interesting was define Detnet specific security components. So the idea is that not every use case requires the same level of security and the same type of security. So the idea would be, in the same way for the architecture we're trying to, or the data plane, for example, provide different elements, different pieces of the puzzle that could be put together for different implementations. In principle, the security stuff could be handled that way also. So there'd be a number of recommendations for different kinds of things. So given that, then each use case implementation could choose from among those. So that's another way of organizing our approach to security. So getting down to the actual technologies, packet replication and elimination, that's something that's kind of distinctive that we're bringing to this Detnet implementation because it's crucial for availability and reliability. What are the effects of that? There are a number of ideas that Andrew brought up that somehow it would be good to think about. Does having those extra packets and those extra paths affect any of the existing security protocols? Does it affect an attacker's ability to inject and validate malicious packets? These are questions. I don't know, but it seems like it would be really nice to be able to answer these things in some kind of way. Similar about for those duplicate paths, is there anything about the way that those paths are determined and how deterministic that process is or non that affects the security aspects? I mean, it's very broad. There's just a lot of different things. If we use logical segmentation between the Detnet and non-Detnet paths, such as the discussion there's been lately on network slicing and so on, it's like, how does that affect things? Is there anything that affects IT type traffic versus OT type traffic that makes any difference in that way. In the sense of query and response process execution, is there differences in the way the IT versus the OT stuff works because we have a converged network that somehow has some significance for security? Are there specific packet fields which need to be encrypted? Because anytime you introduce encryption, it takes time. And how much time does it take? Is that time variable? How does that affect our jitter and timing requirements? Are we going to deal with ingress and egress to the domain, or is that completely in a layer above us and we don't need to deal with that? If we can answer it and just say that's not us, we don't have to do it, then that's a perfectly good answer. I'd like to think that that applies to some of these questions, but not necessarily all of them, perhaps. Similarly, message authorization, it's like if we agree to punt that to higher layers, what happens if the message gets messed up at the Detnet layer? That then would make it impossible for the higher layer to accurately process it. So maybe we have to think about things like that. A lot of the time in security systems, things are monitored at runtime. So again, this may be something that's part of the overall network and not part of Detnet specifically. But for example, a lot of time logging is used in security systems. Is there anything about Detnet that has to be logged? I don't know. These are interesting questions. There's the last line item here about embedding intelligence directly into data packets. This is Andrew's particular research topic, so I'm mentioning it here in deference to him. And if you have interest in that, that's a possible tool that could be used here. What happens if some kind of denial of service attack happens? Maybe that's inevitable and it has to be dealt with, or maybe it can be prevented. I don't know, but things to think about. As we're actually implementing and developing stuff, again, I think these are things that may or may not be in scope for Detnet, because these are more to do with implementation, but perhaps the notion of certification and validation of anything related to Detnet might have some, for example, interaction with the Avenue Alliance, which does certification for AVB TSN devices. And since we're fairly closely related to that, I know the Avenue Alliance has expressed interest in doing certification of the Detnet protocols as they're developed. So it's possible that that may tie in with the security certification or validation. I don't know. When I mentioned this on the list, a few more ideas were tossed out by the group. Tossed out meaning introduced, not thrown into the trash can. How much time required to set up and validate security relationships at PowerUp? As I mentioned before, what effect do the encryption validation choices have on latency and latency variation? And this question of what are the advantages, disadvantages of end-to-end versus hop-by-hop trust relationships? I mean, these are very specific security things that I don't know how related they are to the exact Detnet technologies, but it's worth considering. What about on a Detnet network when you have some kind of security devices on the network or firewalls on the network? What's the interaction with those kinds of devices with respect to security? So we know of some known related security work going on, which I'm including here, just mentioning it. And that's pretty much what I wanted to go over. If there's any questions or comments, I'd love to hear them.
Janos Farkas, maybe just a reflection on your migration question and Avenue Alliance. I guess it's, I'm not sure if migration is the good wording. I would say coexistence of the layer 2 and layer 3 and how to leverage the both together. And in our charter, we have a common architecture for the two, and that's how I look at it. So it's not we are migrating from one to the other, but leverage all the possibilities, capabilities.
Clarifying question. Are you saying TSN to Detnet, or are you saying non-TSN Ethernet and Detnet?
My understanding, maybe I misunderstood. The migration question was from AVB to Detnet.
No, actually, I guess I wasn't clear what I was trying.
Okay.
What I was asked was from pre-AVB technologies to, people, and essentially the people in the broadcast world who I deal with a lot are used to IP level routing, and anything below that they don't really get. And so it's what we're using, RTP now or whatever it is we're using, but it's routable, it's layer 3, and how do we get from here, to there without to continue doing things how we're doing them, but have them work properly.
Okay, thank you for the clarification.
Carsten Bormann, it's certainly interesting to see all this security work, and I like the approach, CIA and all that. Now I wonder, has anybody written up already what the threats are in the first place? Or who are the attackers? What are their motivations? What are the capabilities, we assume, for those attackers? Because you really need to know that before you do the other half.
Well, as we all know, the answer is no.
Okay, good. So my suggestion would be to do that.
Did you just volunteer?
Maybe.
That would be great.
Did he say maybe? I heard
Yeah,
that.
he said maybe. That would be great.
But
That'd
my
be great.
problem is that I'm not as familiar with all these use cases to actually have an idea of who you are afraid of in these use cases. So it would be necessary to get input from a lot of people to probably answer this.
Well,
Yeah,
have I got a use case document for you?
Yeah, one of the things that's really important about the use case document is seeing the commonality. So if you could look through the use cases and then think about what sort of common threats there would be, or we also look to common solutions, but what's the commonality across the use cases, and that we should be thinking about as a working group, because that's really the most important thing about the use cases, is understanding the commonality.
Yes, but then there may be some security threats that are actually very specific to.
Yeah, I was just thinking in my head, do I really want to say and the outliers? But so you
Yes.
said it. Thank you.
Yep, good.
Okay, Deborah Berngard, you're speaking as your AD. When we were doing your charter at the ISG, the security ADs actually had put those couple of lines in the charter to please consider security, right? So I think they will be very happy to see this work kicking off. And I was thinking I can also ask them possibly to help have somebody to help us kick this off, and so that we're not going down blind alleys. It's okay.
Thank you.
Good.
That'd be great. Thank you.
Hi, John Dowdle, Airbus. This is something I have knowledge of on a systems level. I work with the security team quite regularly, so I guess I'm kind of volunteering to have a look. And but just some caveats, really. It's a good idea to analyze each use case, yeah, and say where are the threats likely to come from, what is the impact of a threat being realized. But you can make some general suggestions, but I think every system integrator who builds using this technology has to do their own assessment, because they have to look at it. It often comes down to money. Because an organization will say, well, your security stuff is taking too long, I can't afford that. But you have to fight back and say, what's the cost of not doing it? What is the operational impact to your system? So, for example, if you're in a power utility, some kind of interruption is clearly quite important. If you're in an audio setting, what's the impact of? I suppose there's two things. There's really, is the equipment just going to go wrong and madly thrash about and throw random stuff around, in which case that's an internal threat? Or is it an external threat, somebody trying to inject something into your system for malicious purposes, or I don't know, all kinds of things. Yeah, I mean, we all read the press and see the stuff that goes on. But it's a question of looking at what the possible threats are, and then kind of drawing a line somewhere down the page and go, well, the ones below this line are too expensive to implement. I can't really afford it. And that's what's known in the trade as risk appetite. What are you willing to put up with because you can't afford to fix it? Yeah, but it's so it's a kind of an individual system thing, but it's good to look at the use cases and go, what are the typical threats going to be to this use case to give system integrators an idea of what it is they're going to look for in their own system. That's got to be put at the top. If you're building a system, you've got to do your own security analysis here.
Okay, so that's looking at it from a kind of different perspective than I was taking. I was saying, well, the technologies have security aspects of them. Do you think that there's any point to approaching it that way, or is that really just not the right way to think about it?
Because if you can say, I've looked at the risks to this particular bit of technology or this particular building block in your system, that's helpful to the overall security advisor looking at your system, because you can say, right, so I kind of know what's the likely problem with this bit, but overall you can't tell as a technology provider what your overall system is going to look like out of building blocks. Yes, you then have to take a holistic view over the top. Yeah.
Okay, good.
Yeah,
That's what I was hoping for.
Yeah, so I think particularly Pat Taylor, Broadcom, and I think with my Broadcom hat on, though I'm not sure. I think, given the kinds of things we're trying to control here, the kinds of real world things, and that it's very important for us to pay attention to security and have a handle on where our exposures are and what security kind of protection need. I don't want to say needs to be there, because there's a wide range of applications, but what the exposures are and kind of some idea of how to mitigate them, so your building automation system or your power plant doesn't get attacked. I mean, we've got some industrial applications as well where you really don't want that to be disrupted, and there can be real dangers.
So before you go away from the mic, the perspective of needing to look at it from a system standpoint and understand the real application and tying that together with the potential solutions and costs of those, that whole description actually would be really useful to add to our architecture document in the security consideration section. I was thinking about when you were talking, where does this belong? Does it belong in the use cases? Not really. Does it belong in the solution document? Not really. Well, maybe parts of it. But certainly it belongs, we could put that into the architecture document. We have a working group document already that's there. We have some security considerations, but I don't think they cover quite the scope that you did, a perspective that you did, and it's really useful. So if you're willing to capture some of that, that would be great. And you can just send it to the list and say you'd like to add that to the architecture document, or
yeah, it's industry standard stuff, so there's no real IPR attached to it. So it's something that every system should. I think as Ethan was talking about, do we have a security bit in the top level documents? I was thinking yes, but should you actually pull all of this security stuff out? I'm not sure. It's good to have the lower level technology description stuff with its own security stuff. But yeah, I think that the idea of top level security stuff has also got legs.
Yeah, and to some degree, it's one-on-one stuff. You expect people to know it, but then again, if they don't know it, how do you expect them to know it? So if
I meet an awful lot of system integrators who have no idea about security, and it's always good to have something in writing and say you've really got to pay attention to this.
Thank you.
Thank you. And our next presentation is on cross-hauling. So Carlos.
Okay, good morning. My name is Carlos Bernardos. I'm from University Carlos III of Madrid. And I'm going to present just briefly some requirements about cross-hauling that we believe may be added to the Detnet use case document that we have just went through. So next slide, please. Okay, thanks. So well, the objective of the draft and this presentation is basically to go through this requirement that we have been working on as a result of a European project called 5G Cross-Haul, and to see what if there are some missing requirements from what is already in the Detnet general use cases document, which already covers quite well the mobile networking use case. And then if we identify any difference or any addition that is may be worth to be added to basically contribute to that document. So, well, before going into the requirements that we identify, just a brief overview of what we mean by cross-hauling. This is a general picture of a mobile network architecture. And here we just present, basically we have here on the right-hand side the core of the network. On the left-hand side, we have the access. And just a bit of terminology, in general, is called backhaul, the network that basically connects the core of the network with the radio access network. That's generally called backhaul. And then in the radio access network, if we have what is called a functional split, so basically we have some functionality on the radio side, and then some functionality from this remote radio head. So these antennas, basically these base stations, move to a more central point. Basically, this is the typical crowd run approach. The connection between these remote radio heads and the baseband processing units, which are called BBUs, this network is usually called front haul. So we have in typical networks, we may have a front haul, we may have a back haul, we actually may have even a mid haul. And what we mean by cross haul is basically integrating this back haul and this front haul. So having the same network for the back haul and the front haul. So that's what we call cross haul or X haul, depending on the document. Usually you may find both terminologies or both terms. So looking into a cross haul based architecture, so having this same kind of network for both things. In this project I mentioned, we came up with a set of functional requirements and also performance requirements, and they are listed here. So basically we have, for example, in terms of functional requirements, supporting multiple functional split. And what is a functional split? So basically it's what type of functionality moved from the typical base station to this central point where you move functionality. So you can have, for example, here just physical layer stuff, and then you can move layer 2 stuff here. You may move part of the layer 2 stuff here, but keep part of the layer 2 stuff here. So these kind of things, depending on where you move, you have different functional splits. So one requirement is for this cross-haul network to support multiple functional splits simultaneously. So that's one requirement that we identify. Then we have some requirements dealing with multi-tenancy, so isolating traffic, being able to separate traffic, so having different performance for different traffic, these kind of things. We have also consistent and compatibility requirements, so we have to, whatever technology we do just should be compatible with existing mechanisms like Ethernet or other approaches. We have also some requirements in terms of transport efficiency, so whatever mechanisms, technology we use, we should be as efficient as possible, of course. We should also support having inbound control traffic for management. We should also try to be as more energy efficient as possible, trying to be, for example, the energy use as proportional to the traffic that is handled, these kind of things. I'm not going to go into all the details, just the goal is to basically summarize the requirements that we identified. And we also identify some performance requirements based on AO2.1cm. And I will not go through the numbers, but basically we identify requirements for latency and packet loss, depending on the different radio access technologies that may be supported. So very quickly, this is what we had in the document. And the idea was to, check what is in the Detnet use case document, which already covers quite well this mobile network use case, and see if there are differences. Well, we identify some minor differences. For example, there are some stuff in terms of functional requirements that are not yet completely covered there, and that we believe we could contribute with text. For example, in terms of multi-tenancy requirements, stuff related to the joint backhaul fronthaul operation. And also identify some differences on the performance requirements. We probably need to check with Joni and with the rest of the co-authors what are those differences, whether it makes sense to update or to include also the numbers we have there. And basically the idea is, to have this contribution to the Detnet use case document if you agree that we can send some text to complement that part. So that's basically our goal with this presentation, is not to have a different document, is more to actually contribute with text to the existing one. So you have any comment or question?
Somehow I'm looking at the author of the use case document. Oh, get a different author to come up.
Yeah, Jouni Korhonen, Broadcom. Yeah, sure. I would welcome you to kind of fix the missing parts. Let's put it on. I wouldn't like care about the performance requirements number so much because they differ depending which document you look into, and they are kind of moving target, unless they're like a real difference in scale. So otherwise, those numbers are more or less like advisory. So yeah, so feel free to direct the whatever you find there to Ethan, so he will implement those.
Okay, perfect. So basically, over the next few weeks, we'll send text to the list. Thank you.
Great. Thank you. Feel free to have as much conversation as you'd like on the list. We know that not every conversation is going to work on the list. Sometimes authors can do things a little more quickly, just one-on-one, but feel free to have as much of that on the list. So look forward to that update. So I'm not sure if we're going to do remote presentation here. Actually, there was one change. I don't know if Janos is going to do it or going to try to do it remotely. Class is online. I guess not. Hold on one moment.
Doing it local. Okay, so I'm János Farkas from Ericsson, and this is work we have been doing together with my colleague Balázs Varga on the Detnet service model. And this is still work in progress, so this is the second draft, and we would be grateful for comments and feedback. So what is the goal overall? This has been initiated based on the discussions we are having in architecture, in the data plane, and so on and so forth, that it would be good to have common terminology and common understanding of what is the service, what kind of Detnet service is provided, what kind of Detnet flows are there in the network, and what are the service access points where these flows ends and start. So this one of the main goals of this whole document is to clarify and have a common understanding of the service model via well-defined reference points and components and flow types. I'm going through those details briefly. Here you can see the content of the document. So we discuss different type of end systems connected to a Detnet network, the Detnet service model and the Detnet service instances, and how to carry Detnet data flows over multiple technology domains, and what is the case when there is Detnet flow and non-Detnet flow in the same network, which will happen, of course. This is elaborated in detail in Annex 1, and Annex 2 is a new one I will explain soon. So Detnet flow, do I have a laser pointer? Yes. So this definition is as the Detnet flow is defined in the architecture draft. That is, a Detnet flow is a sequence of packets to which the Detnet service is to be provided. In this document, we distinguished 3 types of flow formats. Actually, we see the benefit of distinguishing these 3 kind of flows. The very basic one is the so-called application flow, app flow, which is a native flow without any Detnet specific attribute. So looking at this picture on top, the app flow is a native flow between the 2 applications on the top. Another aspect, when we add some Detnet service attributes or Detnet attributes to flows, and we distinguish 2 kinds of such flows based on or analogous to the division we use in the architecture, actually in the architecture, but mainly in the data plane discussion. It was introduced the transport layer and the service layer within the data plane, and different parameters belong to to these two different layers, and taking that forward to the flows, we distinguish the Detnet S flow. That is sort of the Detnet service level flow, because it is an app flow extended with some of the Detnet service related attributes like the flow ID or sequence number or both. And the more complex one is the Detnet service transport flow, which is an app flow extended with both Detnet service and Detnet transport layer parameters. So in fact, the Detnet ST flow is encapsulated according to the forwarding paradigm used by the Detnet network. So that's the full-blown flow, if you wish. Following or elaborating more this approach, we can distinguish the end systems. So there are actually three kinds. In essence, an end system is either Detnet unaware completely. So that is the one that sends and receives app flows, or an end system can be equipped with some Detnet functions. And here we can divide similarly to this division, whether the end system is Detnet service layer aware, or the end system is both Detnet service and transport layer aware. We call it just Detnet end system. So this is the full-blown Detnet end system, if you wish. Let's see pictures for these end systems. So the simplest one is the Detnet unaware end system, which originates or terminates native data flow. So this is the one you see here. This is an edge node of a Detnet domain, and this is a Detnet unaware end system. The second one is a Detnet aware end system, which is aware of the service layer. So the flows originated or destined to this Detnet aware end system are extended with the service layer specific parameters. And the full-blown Detnet end node is the one that terminates or originates the Detnet ST flow that is extended with both service and transport layer parameters. So what are these reference points you already saw in the previous picture? This is all these pictures are from the draft, and this one aims to capture all kinds of services you can have in a Detnet scenario with interfaces and reference points. Actually, one is missing. One reference point you will see in the next picture. So the simplest one is the internal reference point for the application flow, which is denoted by O. And for the Detnet S flow, the service layer of our S flow, the end system internal reference points is denoted by a simple V. And for the more complex ST flow, it is W. It is two V's because it covers both the service and the transport layer. So that's why. You will see it in this one in the next slide. And as for the interfaces, we have the user network interface, the UNI, that is on a Detnet edge node, and we can have NNIs in certain deployment scenarios between networks. So moving on to the next one, as I mentioned, the full-blown end system has this W service endpoint inside, and as the figure illustrates, this Detnet end system can be interpreted as part of the Detnet domain, because this is an access point providing both the service and the transport layer attributes. Okay, so this is another alternative, another case for illustration of all kinds of services. So these are the updates we made to the .NET service model, and actually we extended the attribute list with one new attribute. So we had the delay and the bandwidth and so on with a new one, which is the connectivity type. We think it's good to distinguish whether it is a point-to-point service or a point-to-multipoint. Okay, so after introducing all these reference points and different flows and flow types, let's take a look on our service instances. So what you see here in the middle, there is this PSN and a PSN tunnel between two edge nodes. The PSN tunnel transports only .NET data flows, one or more flows. I will talk about that briefly in a minute. So it's but in the transport network, in the PSN, in let's say flow setup scenarios, or actually in other use cases, there can be situations when not a fully established .NET flow is carried over, but a simple flow without any .NET specific attribute yet or service yet. And how do we carry all these different flows, and how do we distinguish them in the same network? So we have a filter at the attachment circuit, for the attachment circuit carrying these flows, and this filter, like F1 here and F2 in the provider H2, is the one that filters the .NET flows from the non-.NET flows, I would say, and associates the given .NET flow to the corresponding .NET service instance. So it's service instance, this service instance in this case. And this service instance does the job what it has to do. I mean, in terms of mapping or bridging or routing that needs to be done in the edge node, that is implemented in this service instance. The service instance can be shared by multiple flows, so as the PSN tunnel. We have an annex that elaborates more this in detail on how to carry different type of flows via the same packet switch network, and gives more examples. This one, we have a chapter on .NET data flows over multiple technology domains. We did not make any change to that one in this update to the draft, so I would not spend time on that. And there is a new annex in the draft. Maybe this draft maybe is not the right place for it, but we have started the discussions on this subject, and for simplicity, we put some initial text to this document. It's up to us to decide what happens to it. So the basic idea here is that in order to leverage the QoS features provided by the two layers, I mean both layers, layer 3 and layer 2, we need some sort of integrated queuing architecture. I was told that QoS may be a misleading word, so read QoS as queuing, and this is intends to be investigating on, okay, how do we integrate the layer 3 and the layer 2 queuing architecture. So as we know, the layer 3 queuing architecture is very elaborated. There are a lot of queuing mechanisms available at layer 3. I guess most people are familiar with the 8 queues, the classic queuing of layer 2 bridges, but it has been elaborated a lot in the last decades. So there has been a lot of extensions to those basic 8 queues. For example, credit-based shaper has been added. One of the recent additions is frame preemptions, and we also have time-aware scheduling, queue draining, if you wish, and there's a work still ongoing on enhancing the queuing architecture at layer 2. So how to integrate and how to leverage both. So this is an illustration of what do we have in a bridge in terms of the published standards so far. So in the bottom you have the MAC layer, and as I mentioned, frame preemption is one of the newest standards which divides the MAC into express MAC and preemptible MAC, and an express frame can preempt the transmission of a preemptible frame, and after sending the express frame, the transmission of the preemptible frame is continued. In order to leverage that, we had to divide the transmission selection in the layer in the bridge, and these are the 8 classic queues for which you can have individual transmission selection, and for each queue there is a gate that can be programmed for time instance, whether it is closed or open at a particular time. So this is the time aware scheduling. So this is just a very brief summary on what we have at the moment in a bridge. And if we look at it when we combine it with the layer 3 Detnet QoS architecture, so you see on top the layer 3 queues for which we have the Detnet traffic, and we have the non-Detnet or best effort traffic. We have to divide it when it comes to selection and when it comes to transmitting it to the lower layers from the top to the bottom, so that the Detnet flows become express flows at layer 2 and at the MAC layer. This figure illustrates borders, these denoted by these axes, which may or may not exist in a particular implementation. And one key aspect to pay attention is that when the flows transfer through these borders, a different service access point is needed for the Detnet and the non-Detnet flows. So we have to distinguish them at each border in order to leverage the capabilities. As I mentioned, this is so this is a theoretical picture I would highlight, and it largely depends on an implementation, which queuing you have, which border you have. So it does not aim to provide implementation specific picture. This is just a theoretic one, and in this annex we just drew 2 kinds of approach to give a hint on what kind of differences you may see in an implementation. So one approach can be a monolithic node design when you have a central chip that interconnects the interfaces, or another approach is what we call the line card node design, when you have line cards and the backplane interconnecting the line cards. Each line card has its own network chip, and going back, so for example, this border is inevitable in the line card based design. So this is just a very initial thoughts on the queuing architecture for further discussion and to decide what to do with it. And so the next steps. The mapping when we have both. So in a Detnet deployment, we may have layer 2 segments or subnetworks, as illustrated in many of our pictures in the data plane or in the architecture document. And then it's still an open item for us on how do we map between flow attributes of the 2 layers, because the 2 layers use different flow attributes. And we have started to investigate these queuing aspects, and I think there are a lot of further open items. So that's it for now.
So it'd be good to get comments before we open the floor. Where do you think you're taking this document? Because it covers a lot of material. It sort of keeps covering more stuff. It's good information and it's good background. Personally, I think for the group. But where are you headed?
Well, I think it would be good to have a working group document for the service model, or whether it is an independent document or not that specifies the flow information model. Maybe it's the same document, but kind of that's so one of our deliverables is the flow information model,
Absolutely.
and we in fact started to investigate the different type of flow. So maybe that's the direction we should direct this document.
Well, maybe we should hear from
Yes.
others before I comment.
Pascal Hubert. Oh, it looks like a lot of that has to do with the architecture, right? Those reference points, I mean, the flow identification. And does it make sense to merge some of this work with the architecture?
Sure, we
I'm
can.
used to find reference points in architecture documents. I mean, that's kind of obvious.
That's a reasonable thing to consider.
Yes.
Although maybe my co-chair is about to disagree with that statement.
Where service points are is certainly part of architecture. I'm not sure if when you get down into the details of service points, whether that doesn't end up to be something you want in its own document, so that because it can get to be a fair amount of material. So I think, you know, the fact that it's desirable to have service points at certain places and such, I think is certainly architecture. But when you start describing exactly what information flows across is supported at each service interface, that maybe gets down to a detail level that deserves its own document.
Yeah, I actually agree completely. I think the information flow really needs to be separate. That doesn't mean it can't come from this document, but I think eventually it needs to be separate. I also think having a document that we sort of evolve and then figure out where it goes is fine. And it's fine to take pieces and bring it into the architecture document. You can work with Pascal and Norm, the other authors, to figure out if there's some pieces that make sense to peel off. And come to the group and propose that. I think that's all good. Having an overall service document isn't something that we had identified as an important deliverable for the group. That said, it seems like it's capturing useful information, and whether or not we eventually publish as an RFC doesn't mean we still can't use this as a foundation for bringing in text into the group and then into other documents. So I think it's worthwhile to see what the group thinks about bringing this in as a working group document. How many people think that the type of material that we've reviewed today is a useful thing for the working group to be working on? So just a few people. So maybe I'll try again on the question. Go ahead. Name, please.
Jouni Korhonen. So a question. So this document has some information in places that is, I would say, very useful, especially when it goes to the queuing part, L2, L3 part. And some parts, honestly, I find still a bit confusing time to time. But certain parts are like getting to which is really useful. So can we ask that like things the parts of the document are useful or the whole document? So that's basically what I'm asking.
I'd say that again.
Can you phrase the question like the parts of the document are something what we find useful, or the whole document? Because, for example, for me, it makes difference.
Yeah, I agree. I find parts of the document more useful than others. I personally find parts of the document very confusing. It doesn't mean that other parts aren't.
Still there's room for work.
Let's go to the floor. I think you were first, and then
Ning from Huawei. Yeah, this is useful. But I think when I read the service model, first I assume that it's more about the application or the upper level characteristic. But when I read the following slides, I think it's more like a networking, or I would prefer to echo with architecture things. It's more like can be reflecting the architecture as well. So Yeah, I think it's useful, but it's more related to architecture, in my point of view.
Yuan Longjia from Huawei. I think this document is quite useful, and I think I see some similarity between this draft and the MEF architecture. But I do have some thoughts on what's the exact things behind this service and the transport layer. Actually, this thought is not only with this document, but also with the architecture and the data plan document. Actually, I see in the architecture document, the PSN is the transport layer. You use the control protocols to together with the TSN data plane. But for the data plane document, the TSN Ethernet traffic is actually a service. So I see some inconsistency between these documents. So I would like to see what clearly is the work group is targeting it.
And that certainly is a risk with bringing this document in on as a working group document as it stands right now, because we have working group documents, those take precedence. We have non-working group documents, it's individual. Individuals would say whatever they mean, they don't have standing. But then if you want to get the working group to fix the document, you're sort of working on it. So does that make it a working group document? You know, so once it becomes, while it's an individual document, he controls it. The author chooses what goes in it. Once it becomes a working group document, we control it. So,
definitely, as a work group, we need to develop this as a whole. But my other point is that there's inconsistency between the architecture document and the data plane document, and I see some maybe we need to find out how to
that's a great thing. That's a great thing to bring up on the list. I mean, that's not related to this document. It's maybe more related to the next slot, even though it's not completely related. That's a good thing for the list. So I mean, the question I wanted to, the rephrased question is, how many people think that working on service models are important to the group? I think we have a few people there, and I'm not.
I sense that we have some confusion or disagreement about what the meaning of a service model is, because to me, a service is something a lower layer offers to a higher layer. I think I heard some people say, well, a service model is something you have at the application layer, but as I understand it, anytime you have a lower layer offering capabilities to a layer above it, whether it's the network layer, the transport layer, or the link layer, or anything, that has a service layer at the top of it that's kind of the uniform way you describe what that provides.
Yeah, I agree with the statement completely. The confusion I was going to say is I think we have confusion over what this document is actually doing. Maybe it's too early to ask if we want to make it a working group document, but I think we've identified a few pieces that are worthwhile to peel off, potentially take the document, take parts of it and move it to the architecture. So if you can work with Pascal and Norm on figuring out what parts might be good for the architecture document, and if you think there's other documents, working group documents, that would be good too. And then finally, look at the information flow that you've started talking here and look at it as a separate piece of work and try to bring it together in a broken out document and as a more focused and well-scoped document. It may be easier for the working group to digest.
Yes, yeah. This is, I guess this confusion partly comes off that we try to address what is not clear and what is missing from the other documents and these service access point, the different type of flows and so on and so forth. So that
There's a
But
lot of
I
good stuff,
fully
but,
agree
but it's
that-
really broad.
Yeah,
I
so
fully
let-
agree that it would be nice to figure out what should go where. And
Yeah, let's-
then,
Let's spend the next cycle refining it and kind of moving the things out that really should be someplace else, and then getting a more honed document.
Yeah. So looking forward to seeing you take pieces out, put it to the architecture, take pieces out, and really do the information model. Yeah. Thanks.
thank you.
That we're going to move on
Data plan.
to data planning. Yon.
Slides,
When?
just like a few minutes ago.
No.
Can you?
You have a computer?
I have it.
Well, if they're uploaded.
They upload.
Oh, you uploaded.
Yeah.
Hey. Okay. Give me a minute.
Because I can.
This is why we don't try to upload on the fly.
Yes.
Give me 1 sec. Why don't you bring your computer up and we'll race? See who gets there first. Seriously.
Well, I've almost got it up.
HDMI or VGA?
I've got it. Right.
Okay.
You may just have to save me. Okay. Is it Control F? No, it's not Control F.
Control L.
Control L. Because that makes sense for full screen.
Yeah.
That's a long presentation. I'm not.
He's on information flow.
Oh, did I upload the wrong one? Okay, hang on.
Just changed my name.
Yeah, sorry, I must have clicked on the wrong thing.
He's just trying to get us back on schedule. We were a little bit ahead.
Yeah, we were 1 minute ahead, so sorry about that.
Oh, I see. When you uploaded it, it put it in at the end.
Well, that's what the system does.
Yes.
Drag and drop.
All right.
I don't know. It's thinking. Don't think. Just do. There.
All right.
There we go.
Thank you. Thank you for your patience. Okay. So, this is about the data plane discussion, and the just want to say something that you will find quite a bit similar things that was already in the previous presentation, because there's a certain things that kind of they overlap because they are on the same topic partly. And the I want to bring you back, like in IETF 94 we had a kind of teaser presentation about the one way of doing the data plane for Detnet. So you can go and check the proceedings for the slides on that. And as you know, that we had a good design team that looked into the number of different Detnet data plane alternatives, and we produced this working group document that is out there. It hasn't been updated for a while, and so what we have in this presentation, this presentation looks into a possible data plane solution that the and it's kind of based on the design team document input, and it definitely does try to kind of bring the attention to a certain set of solutions. The next slide, please. So if you remember from the last IDF meeting where we had the kind of presentation about the data plane design team progress, we came up with the current thinking, like there's a bunch of different technologies, but we ended up saying that we have a set of like 3 different solutions that seems to fit the purpose with the kind of least changes or least additions or new inventions. So we came up with the pseudo-wire over MPLS or pseudo-wire over IP PSN or just RTP UDP are things that seem to fit into what is the Detnet data plane. And we also had this discussion like how many options we choose. So if we choose one, so pick one of those, okay, it makes the kind of documented the solution easy because you have only one thing to care about. But it doesn't mean that it would fit all the use cases and doesn't necessarily make sense in all cases. So, okay, what if we choose one, like starting like from the L2 interconnect and the like a native Detnet end-to-end use case. So there we have two things to worry about, but we can still have a reduced set and concentrate a couple of relevant use cases. And really, we shouldn't kind of look for more. And if whether the more use cases come up that we need to kind of cover with the data plane, I have that kind of feeling that once we solve these two, like L2 interconnect and the kind of native end-to-end Detnet, we can figure out the rest out of those two. Okay, next slide. So I have the assumption in mind that there's a QoS mechanism in both layer 2 and layer 3, and they are in place. And there's a sufficient queuing and scheduling mechanism in place in every layer that we need to care about. So the data plane doesn't really need to kind of go into those. And again, then the service model document had a great deal of this discussion already. Okay, next slide. So you remember this Detnet enabled network example, what we had in the data plane document. So this is something that I built up everything from like a reference to this same diagram. Okay, next slide. Okay, this is not the latest one. This is not the latest, but it doesn't matter.
What?
Anyway,
This is not the next slide?
this is not the latest
It
document.
was what was on the,
Whatever. Okay. I'll continue. Don't worry. Okay. So the thing that we have the service that we need to look into. So we have Detnet end-to-end case. So this is the case one. If you go into a data plane design team document. So this is the case one, end-to-end Detnet. For example, you have an
We're going to
RTP
switch you
flow.
back. We have the latest here.
Wow. Okay. Can I now switch this one? Oh, excellent. Thank you.
Now you can.
Then we have the TSN interconnect case. So we are connecting two layer 2 TSN islands over some other network. And then we have the service translation, which is the case 3. So we have a layer 2 TSN network, and we have the Detnet network in between, and then go back to a TSN network. So basically, the case where UL2 has grown too big and you need to route packets, and then you go back to layer 2. And then we have the service interconnecting case, it's a form of the previous one. So you are connecting, for example, TSN end systems with the Detnet end systems. So the case one. So we have a Detnet aware end system, or how the service model call it, full-blown Detnet end system. So they initiate the traffic that and the end system. They fully know that I'm going to talk over to a Detnet network. So this is one of the interesting use cases that I think we should kind of cover from the beginning. The next one is the TSN interconnect. So basically, you just extend your layer 2 over a network, another network. Basically, you have single large L2 TSN domain. And what it looks like is like a TSN over EPN, EVPN prime, EVPN plus, whatever, with quality of service. The third case is the service translation. So you terminate, for example, your TSN system, you do proxying, you can even look into the payload, you understand quite a bit about your service, you go over to the Detnet network and go back to TSN. And this is the kind of variation of the previous one. Anyway, so recapping a couple of the key features that we need to support. So one thing that is really important is the flow identification. So how we identify specific deterministic flows. Reliability. So this goes back to flow duplication and merging, and also like how we sequence packets and figure out duplicates. And so these two things go together. So the sequencing and flow duplication merging, they all about the reliability. And of course, we have the queuing stuff below and way of identifying more important flows so that we have zero congestion loss and bounded latency for Detnet traffic. And more about the things that when it comes to a kind of the data plane encapsulation, so flow identification. I have a couple of examples like 802.1 CP does. It has a map plus VLAN, it has octuples and so on to identify flows. In Detnet, it would be desirable that we had one way of doing this flow identification in a Detnet domain, and that would be actually the actual transport, Detnet transport independent. Sequencing, again, I refer to a couple of existing technologies like a CB has an AirTag that has a sequence number. Couple of other technologies, they also have the existing sequencing mechanism. And again, in Detnet, this should be a transport independent one mechanism that actually is able to interwork with all of these existing ones. And timing, so this kind of question that I have, like do we actually need to carry timing information as a part of the Detnet flow? So that would be something that like a timestamp information is transported along with the Detnet packets as part of the Detnet header. So the prior work, so okay, I refer to a couple of things. So for example, first the design team document, and also that document is still work in progress, but is leaning towards the fact that the like multi-segment pseudowires is something that is very close to meet the what is needed from the Detnet data plane. So we can map a couple of things into multi-segment pseudo-wire nodes, like Detnet edge nodes would be TPEs, relays would be SPEs. We could use pseudo-wires to transport Ethernet payload, packet pseudo-wires transporting any other packet types, sequencing and duplicate elimination using controller sequence numbers. If we need timestamping, there's a precedent existing work of doing that with pseudo wires on TDM over IP and so on. Flow identification, you can have your PV labels to kind of label your flows, and that's the transport independent. And again, the whole thing we can transport over either over MPLS or IP, and I think that pretty much covers all the needed transport mechanisms. Redundancy and protection. So if we level that up to a pseudo wire level, that can be done so that you can switch the transport below and your how you do your flow duplication and how you do your merging, and this stuff is independent of your actual transport, and that looks like a good feature. Also, in some cases, as you know, the pseudo wires have the NSP native service, whatever that is. You could also do that in that part, but again, then that would be kind of technology specific and scope the solution transport layer only to carry Ethernet-based traffic, which might not be the useful outcome. So assume that we had actually a pseudo-wire-based Detnet data plane. So packet formats at the end, I'm very interested about the packet formats because you need to put something on wire. And in the case of pseudo wires, there's a lot of information already about existing work done. So it basically becomes something, I have these Lego bricks that I need to kind of put into right order. So there's not really much invention to do there, which is a good thing. The service lever semantics, what actually happens, like if I need to, for example, end a TSM service and recreate a Detnet. So how I do that, how I do the kind of like the redundancy and reliability, like for example, if I want to do a similar type of service that I have with the IEEE.1CB frame replication, elimination for redundancy, how I would do that on the pseudo wire. So those are the things that I need to look into. I don't have the existing mechanisms for those. Okay, so going for the actual how stuff would look like on over the wire. So this comes from the RFC 39H5, so the pseudo wire architecture document, and how you would actually map that on the into a specific transport. So we have the PSN that can be on, in case you run that over MPLS, you have an outer label, or you can have MPLS over IP, or just IP. Then you multiplex in layer, which is basically the layer that you do the flow identification. You can have your pseudowire label, and again, it's independent of what happens here. We have existing methods of doing sequencing. If we need timing, there's existing documents how to do that. And depending what is our actual application payload, we might need a conversions layer. So for packet, we look into the how to do a packet pseudo wires, or if it's the application layer is something over Ethernet, we have an existing documentation there how to do that. So this is just basically like a layering Lego bricks on top of each other. A bit more about this. So this is just showing the again, I just want to kind of point out about some of the overhead. So there's something that we need to live with. So this is going to increase your packet size a bit because there's an extra information that we need to put there. And so overhead is obvious, and that is something that we need to think about. For example, in a case if our actual service flow is, for example, something over RTP, UDP, because that flow already basically has everything. But if you transport that over Detnet, it might be still a good thing to kind of have a unified encapsulation so that you don't have multiple ways of looking into in a box. It's like looking into the traffic, like how I identify this is the specific flow and what is the sequence and so on. And one thing, this is like my personal opinion, that optional feeds are bad. I don't want to see optional feeds because they kind of make the passing of the packets a bit more painful. And the and what I have in mind that I assume encapsulation for all application flows, and definitely that might be suboptimal in certain cases. Okay, and then for the kind of, if we have a Detnet native format that we want to have, so we have an application, we have again the same encapsulation there. So this part, the kind of what I have as a pseudo wire header, it's going to be all the same. It doesn't change, but I have no idea what actually I'm going to transport there. So whether this transport layer is something like what is my actual transport protocol, I don't know that yet. That is something to look into. But the key point is that the Detnet headers are unmodified. So I have a unified layer there.
Can you go back one?
I can.
Thank you. I just want to point out, particularly to our AD, that question mark area is something that we're not actually chartered to work on.
Right.
And in fact, really belongs to a different area.
Yeah.
And, you know, maybe we have Quick, and we'll work with the Quick working group on how to adapt Quick and onto Detnet.
Yep.
But that's a question mark for the future, and actually doesn't belong to us as a working group.
Yep. Yep.
The prior one, which covers the interconnect case, is
Yep.
in our charter.
Yes. Okay. Okay. So handling of the service. So coming back to this kind of what we are supposed to work on. So like, okay. So if you go, remember the diagrams that I had, the Detnet end-to-end use case. So that's something that we need to figure out. And it can already use the building blocks that we had some earlier. So those encapsulations. And then we have the TSN interconnect. So, oops. TSN interconnect. So, well, there's not much to do. So it's basically no EVPN type of solution with call it a service. So that's why EVPN Prime. And I think that once we are done with this, so we figured the encapsulation for this type of flows and use cases, we can look into the other stuff, like where we have the service translation and service interworking. Because they do need quite a bit of more work, I just listed here. I'm not going to spend time there, but there actually I would start to care things like I have an existing flow coming, it has its own sequencing, how I put that into a Detnet sequence and how I recreate that on the other side. So these kind of things, whether they are like a common sequence number base or everything is independent, how I create the MAC addresses on the other side and on the other side of the service translation. So, and do I care that I might have the same information in multiple layers? So, for example, if I'm transporting existing, for example, existing .1 CP flow that already has the sequence numbers, do I care that my Detnet layer also have a sequence numbers? Or if I have an RTP flow, do I care that I have the flow identification, I have timestamp, and I have the sequence numbers already in RTP that I'm carrying? So these things are something that actually needs a bit more thinking, and I'm happy to kind of push them a bit forward and take the easier ones first. And it goes on. So there's a pseudo-wire specific issues, like especially on the when you start looking into the protection and stuff like that. So especially the hard thing to me is like how I would do the protection and the reliability thing. So where I actually do the split and how I do the merge. That is something that is going to touch a bit about what is the current definition of the pseudo-wire forwarder and the pseudo-wire instance. We need to look what we need to say there. Okay, so at the end, so the Stroman proposal, what I have is like we really start looking into a pseudo-wire based encapsulation for a Detnet flow. And we look into the multi-segment pseudo-wires. From the beginning, the PSN can be either MPLS or IP. We look how to model the specific set of Detnet nodes, like the relays and edge nodes and transit nodes over the multi-segment pseudo-wire nodes. And encapsulations, we would define how to use control words for sequencing, labels for pseudo-wire labels for flow identification, and then look actually whether we need to care about the timestamping at all at the Detnet level. And the service protection, how this should be done. So like how you actually realize that using the pseudo-wires, how you do the flow split and merge and duplicate elimination. And so basically coming from the first slides, so we have these two cases to look into. So discussion and next step, I invite the discussion, and I have one proposal there already, and that's for the chairs. So like a.
You want to have some discussion first, or you want to go to your proposal?
I don't care. Well,
Let's see. Do we have people who would like to comment on? Go back. Comment on the straw man and also on the what's been discussed.
Something to clarify.
Did you just state your name, please?
Yuan Nongjiang from
Thank you.
Huawei. Thank you. I just wonder, what's the definition of Detnet service? What is exactly IP service or Ethernet service? And what's the relationship between the Detnet service and the TSN service?
I flipped the slide for you.
Yes.
I don't know if you want to answer or you want.
oh, yeah. So you want to say something? Well, feel free to. So for us, the Detnet service can be an Ethernet service. It can be an IP service. We need to kind of be able to cover both.
So for what I understand, TSN is just a subset of Detnet service. So, right.
TSN is a IEEE way of delivering services that seems pretty similar to TSN.
It's a
to
terminology.
Detnet, but inside a very constrained use case. Our use case is different than their use case. They are only concerned within an IEEE 802 domain. It's a single domain. So that we have multiple domains over router-based networks. So the addition of the router-based networks takes us from TSN to Detnet. Detnet also has the notion of Detnet native service, which is not independent of TSN. So we may operate completely without TSN.
From the transporter point of view, Detnet has its own technology, specific thing, and TSN will have its bridge specific processing functions. But from a service point of view, I believe, especially from it's both of them are Ethernet traffic, so I cannot distinguish between the if the Detnet is Ethernet and the TSN traffic is also Ethernet. I cannot distinguish between them from a service.
Well, you can because of the layer the service is provided at, and therefore the packet formats, the headers. And
so you mean the service layer in the Detnet network?
Yeah. I mean, it's the difference between having a layer 2 service and a layer 3 service, and the capability can be that's provided as far as the latency achieved and such can be similar, but it's what the underlying network is that it's built to go over.
Sure. For underlayer network, it's different. But just as we take the example of MEF, they define the UNI, such a concept. From UNI, the TSN traffic and the Detnet traffic will be the same with Ethernet.
So if you're operating, so MEF operates at the Ethernet level.
Yeah.
So if I operate at the Ethernet level, whether I'm delivering random datagrams over Ethernet or IP over Ethernet, I'm delivering an IP service, so I won't see a difference. And the reason is because the service interface is an Ethernet service interface, and that's what you have with MEF. It stops at Ethernet.
Yeah, that's
with what we're doing. Sorry, with what we're doing here, we are fundamentally delivering an IP-based service.
If it's
an IP-based service can operate over Ethernet,
sure,
or it can operate over whatever network
that
technology you have. Detnet is designed to operate over whatever technology you have. Now, one of the things we also do in the routing area in the IETF is build layer 2 VPNs. And one of our use cases is layer 2 VPN that happens to be a TSN domain. So one of our services that we're going to offer is layer 2 VPN over Detnet.
Yeah.
So
Actually,
we have
we-
those two. Those are our two. That was use cases 1 and 2, and then 3 and 4 you can think of as combinations of those. But really, fundamentally, we have 2 things that we're looking at from a service model: end-to-end IP-based service, and then a layer 2 VPN TSN interconnect service.
Yeah, maybe we need to split between the interface of CE to PE or PE to PE. From PE to PE, you can use any kind of transport protocols, GRE, L2 VPN, L3 VPN, IP, such things. But for CE to PE, you still need to define what is exactly the service format.
Right. So we have 2 use cases. One use case is 802.1 TSM.
Without any.
And that's use case 2. So this is one. This is one thing that we're doing. Another one is that we have a Detnet native service, which is an IP-based service.
Okay.
So you may have Ethernet, you may not have Ethernet, but there's going to be IP.
Yeah.
And then the question is, what's over IP?
So it comes back to TSN traffic may still be the subset of the Detnet.
No, TSN is an IEEE piece of work. We don't control that here. It's
not a work.
That's
it has nothing to do with the network, but it's a service.
It is responsibility.
It's a service. when I receive some Ethernet traffic, it may be some normal Ethernet. Maybe it's TSN traffic, right?
I don't want. Yeah. I'm not sure that you're asking anything different from that. If I'm an Ethernet switch and I get IP traffic, am I doing IP or am I doing Ethernet? I'm not. I think we should take this offline because there might be a point here that I'm missing, but it sounds like you're just fundamentally asking the difference between the layer 2 and layer 3.
Maybe we just need to clean up the terminologies so that it will be more consistent.
I think we're pretty consistent with the rest of the IETF at the moment.
Yeah, IETF and the architecture. So these are pretty much aligned.
Yeah.
And if you have specific wording changes that you think to cover your point, that would actually be hugely helpful. If you look at the documents and say you think this piece of text is wrong, and that to fix it, you'd like to see that piece of text, and that's a really good way to make your point crystal clear.
Yeah, we can discuss it offline.
Okay.
On list, please. Thank you.
Lin Zhong from Huawei. A very quick clarification because it begins confuse me a little bit. So you mentioned that we also want to build IP service end to end to achieve the deterministic latency, right?
Yeah, to case 1.
Okay, so I'm confused. Without the support of the data plan, I mean the device layer 2 or something, how could we achieve that? Because we assume any kind of device underlying, so how we could achieve the end-to-end?
We certainly would expect that the devices underneath implement the appropriate queuing and other traffic management capabilities.
Okay.
They may get it from a particular subnet technology. For instance, they may say, we just get it from 802.1 TSN. Or let's say they're on an MPLS network, they might get it as an MPLS service.
Okay, so we do have such kind of assumption, right?
Yeah,
Absolutely.
so like it says here,
Yeah.
sufficient queuing and scheduling mechanisms are in place.
Sorry, I maybe missed that. Just want to clarify. Thank you.
It's actually a really great point because we can get wrapped up in thinking that Detnet is trying to solve everything. We're not. We're actually trying to use as much as we can of what's out there.
Okay. Yeah.
And we're happy to reuse and leverage any underlying link layer technology, whether it be specified by this group, let's say through traffic engineering, or through another group like IEEE TSN. We're happy to take it from anywhere, and we want to leverage that. We don't want to invent it all here. If we were trying to invent it all here, we'd never get done.
Yeah, makes sense. Thank you very much.
Okay. Yeah, I think maybe now it's a good time to go from examining this to the question of how do we get from a data plane alternatives draft to a data plane draft.
Okay.
So now your proposal.
Yeah, my proposal was that we had a design team that kind of that already came up to this point. So my proposal would be that okay, there can be a multiple individual draft. That is also an approach, but I would propose that we reincarnate the design team, and actually I would open it for some new phases.
Sure.
Because we had some loss of participation and stuff like that. So
well, also the skill set needed to do a survey, which is what the original charter is different than doing a deep dive on an implementation. So I could see. So again, just to clarify, what I heard is there's a proposal to reconstitute the design team rather than as a data plane alternatives one, but as a data plane solutions document and design team.
Yes.
And that would include revisiting membership.
Yes. So the old members are of course welcome by default, but they also can kind of drop out if they want.
Sure.
John Dowdle, Airbus. Yeah, sorry, I was a bit concerned about how you assure the underlying transport as well. So yeah, happy with your assumption that that kind of is done. But could I make a suggestion that maybe you give one or two examples of how that might be configured, just so that we can assure ourselves that it is technically possible to.
Oh, you mean the underlying?
Yeah.
things?
Well, how would you configure this underlying MPLS or whatever, just to make sure that the stuff does arrive at the right time it's supposed to, always can be realigned at the other end?
Yeah, so that I think goes to the other deliverables.
Yeah.
And the whole deliverable of the working group. So as a working group, we have to do that.
Oh, sure, yeah.
As specifying the data frame format.
It's a different from that, yeah.
Yeah, I'm not sure that belongs in that same design team.
So as
But,
Lou said,
but then again, picking technologies that actually can work is pretty important also.
Yeah.
So it's about
It's just to assure ourselves that there is actually sufficient underlying technology to do that.
Yeah.
I haven't got experience of MPLS, so I couldn't say one way or the other, but it's just to assure ourselves that we're not building on sand, as it were.
Do you want to volunteer to participate and contribute for other technologies?
I'd volunteer to go and drag somebody out of MPLS and say, please tell us how this is done. But yeah.
Sure.
Yep. Okay.
Fair enough. Any other comments? We think this is a reasonable way. If you're interested in participating in such a reconstituted design team, which we are not announcing at this point, we're just considering, please let us know. The chairs know, or you can contact the authors, Ione, as well. But let us know by email or coming up and talking to us after the session. Okay. So with that, we're going to move to the next. Nope. Sorry, hold on one moment. Looks fine on my screen.
I've got the updated version. Posted an updated version 28 minutes ago.
Just sending.
Yeah. he
Did
just sent a
it
new
get
one.
uploaded?
It's in an email.
Because for this one, I've got some typos.
I think you have to live with the typos.
Or I can present. I've
Okay.
got it.
Sorry for
I just saw it on the email.
You won't have to click. You'll have to tell.
Oh, okay.
I'll tell her and I'll have to be awake.
Yes.
Okay.
Okay. Hi, everyone. This is Yong. Today I'm going to present the update of Detnet flow info model draft. This draft was submitted before Berlin, and we got some comments of that, but not much. I think definitely we need more feedback in order to push this work forward. Next, please. So basically I'm going to highlight the update of the draft. So first of all, we add more information on flow identification and the traffic description. These two parts are very important for boundary delay service provisioning. And also we made some editorial changes. Next, please. So this draft is all about how to describe a Detnet flow and what kind of information should be, what kind of information of the flow should be standardized. In my opinion, an info model should define some common concepts of the Detnet flow, and they can be mapped into data models and being used by network functions. For example, flow identification, data plane configuration, resource reservation, control protocols, and the YARN models. So currently we are more focused on the flow identification and the resource reservation. Next, please. So first of all, the flow identification. So for Detnet, it provides boundary delay service to certain kind of flow, which should be first identified. So network first need to know which one is the Detnet flow, and then use the dedicated resource to serve the flow. And actually, right now there are some existing technologies can do that. For example, we can do flow identification in layer 2 using a VLAN ID and the MAC address, as mentioned by Yoni. And usually access network, the flow identified by some layer 2 techniques. Next, please. And also we can do flow identification in layer 3 using port plus IP address. So here the question is this kind of flow identification mechanism is enough for Detnet, or maybe we need something new for the deterministic service? Next, please. And also, we need information about the flow traffic description. So for Detnet, it needs to reserve dedicated resource for the flow in advance. So which means the description of the flow, description of the traffic may help to make better resource reservation. Is bandwidth reservation enough? I don't think so. A lot of research and works show that owning sufficient bandwidth cannot solve the latency issues. Next, please. So, and also shaping is very important for providing boundary delay service. As mentioned by Chair, on mail list, the network cannot provide boundary delay to an unbounded flow, which is very important that the boundary delay service only works for the flow with limited burst and bandwidth. So how can we guarantee the traffic from the source? Or in another word, how can we limit the source when it is sending traffic? Shaping can be helpful, and shaping has already been widely used in the current network, together with queuing and the scheduling mechanism. So in my opinion, we need to standardize also the shaping mechanism in order to get the pre-known latency information. Next, please. And actually, shaping parameters are not something new to the network. In ISVP, it defines flow spec, which provides the token bucket shaping parameters, for example, token rate, bucket size, and so on. Next, please. So in this draft, we define shaping parameters with both liquid bucket and token bucket, which are two most widely used shaping mechanisms in the current network. So here the question is it enough for Detnet, or we need something new? And also, can it be used by the application? Maybe the application can use this parameter to tell the network the maximum attributes of the flow it is going to send. Next, please. And also, we try to provide some applicability of the info model. First, the service needs flow information. As mentioned on the service model draft, the flow attributes can be mapped from up layer to lower layer. Next, please. And next, the flow information is also needed for control plane. For example, the PCE. For path computing, it needs flow information, traditionally bandwidth only. But for Detnet, latency may be also included. Next, please. So currently, this draft is only the second version, is not stable yet. And of course, we need more information and more feedback in order to push the work forward. So basically, that's it.
Janos Farkas, you mentioned you have not got that many comments for the previous draft. As far as I know, you got one at least that I would like to repeat here for the second draft, that I believe it is not that useful to start this from scratch. given what is already said by multiple presenters today, that we need to have a sort of integrated model to leverage both layer 3 and layer 2. And there's ongoing work in IEEE 2.1 mentioned by ITEM QCC, for example, that is already on the radar of AVNU in order to use it, that defines a flow model. So it would be better to leverage and build upon existing stuff and extend that instead of doing it from scratch.
Pat Thaler with my 802.1 participant hat on. I think what we found generally in 802.1 is that to control deterministic latency to the point that we need to for some of the use cases, the token bucket and schemes and leaky bucket schemes didn't give precise enough a rate of emission in order to prevent situations where just packets built up, too many being simultaneously emitted into the network. We found we needed to go to other mechanisms in order to control for the very latency sensitive apps.
So, I mean, Janos, again, if I was not clear, I would suggest to take a look on IEEE 2.1 QCC and investigate how to build upon that. What is needed? Yang is included in that one. Information model is included in that one. So on and so forth.
So you earlier talked about doing something on the information model side. Maybe you can contribute that perspective, and then together we can get you guys to work together to come up with a more comprehensive proposal to the group. That'd be great. Thank you.
Thank you.
So with that, we're actually a couple of minutes early. Are there any other topics that folks would like to bring up at the mic, or are we going to break 3 minutes early? All right, go enjoy lunch. Thank you very much. I think this was a productive session. Look forward to the follow-on contributions.
3 minutes early to get ready for the working group challenge. Bring it wrong.
Yeah, I actually wasn't gonna go. I wasn't gonna go, but I think I'm now available. Okay. So we can run down into the
Yeah, that's right. I went down there for dinner last night and scoped out kind of places like viable for a takeout one.
You know what I really want
Oh, I didn't see any of those.
I need like a 7-Eleven. I mean, those are too high end.
The nori kind of wrap.
Yeah, exactly.
Yeah.
The rice
crinkles. Yeah, those are pretty good.
I really like those.
I don't recall seeing any of those.
I saw that. I actually did walk into the convenience store, but on a different part of town. We were walking around, and I had that and a no, I only had a coffee drink, which I also like. But I saw these.
So they do exist here.
They do exist. Actually, someone else got one, and it was a kimchi flavored one. So I thought it was very appropriate.
Oh, that's very crispy. There's one store getting all
Thank you. Appreciate it.
You talk with the same team in case you should not help. I would be interested. I send you just an email.
That'd be great. That'd be very good. Thank you. Deborah, where's the